Okay, here it says find the equation of the tangents to y equals x squared from the point 2, 3. Okay, why have I written tangents? Because more than one tangent can come from a point. Think about this. Y equals x squared, you know, is going to look something like that. Forgive my drawings, you know, I'm a bad drawer. But can you see? Let's just say I've got a point here. Let's say here's my point. I could have a tangent going to the curve there. That's a tangent. Yeah. I could have another tangent going to the curve there. So it's a tangent at two different points coming from the same external point, you see. So two different lines here, two different equations. They're both tangents to this one curve and they're both coming from this one point. Okay, so that's why I've written tangents, because there could be more than one. Not always, but there could be. Okay, so I know that, let's say this is 2, 3 here. Okay, this point here we're going to call A. Let's say, yeah, let's call it A. And then what would the y value be? If this is y equals x squared, this curve, if my x coordinate is A, then isn't my y coordinate x squared? So if my, sorry, I should say A squared. If my x coordinate is A, then isn't my y coordinate A squared? Do you see that? All right, so I know this point is A squared. I know this point is 2, 3. Okay, so here's my function. Function's x squared. All right, let's get the derivative, like we always do. So that's the slope function. Okay, so at point A, what do? You guys should know, I sub in A. So it comes to, instead of 2x, it's 2a. Okay? So at this point, a squared has the slope of the tangent is 2a. Alright? Therefore, actually I might work over here instead of going over. So therefore, just like we always do when we find the equation of the tangent, we go, alright, so y take the y coordinate, y take a squared over x, take the x coordinate, so I'm using this point here, it's going to be equal to the slope of the tangent. Okay, so that's equal to 2a, isn't it? Rearrange this, so that's going to be 2a times x take a. Okay, that's going to be y take a squared is equal to 2ax take 2a squared. Okay, let's collect up some of these what are they called? Like terms. So that would be a squared is equal to 2ax minus a, or minus y. Okay? So that's the equation of the tangent. I'll write that out bigger again. So the equation of the tangent, okay, is this. We'll write it in, we'll say it's 2ax take y is equal to a squared. So that's the equation to the tangent that touches at that point. Alright? Now, but we know this tangent here, we know this line passes through the point 2, 3. We know this line, so that's the equation of the line, but it passes through this point 2, 3. Okay? So when x is 2, y is 3. So I can go, okay, alright, when x is 2, y is 3. Okay, so that's going to give me 4a take 3 is equal to a squared. Okay, so a squared, I'm going all over the shop with my piece of paper here, but that's all right. A squared is equal, take 4a plus 3 is equal to 0, isn't it? Okay, so here's a quadratic that I can solve. Factors of c that add to b, the factors of, so that'd be -1, -3. So a take 1, a take 3 is equal to 0. Okay? So a is either 1 or 3. So therefore, if a equals 1, the tangent equation would be, I'd go 2 times 1 times x take y is equal to 1 squared. So that's going to be 2x take y is equal to 1. So when a is 1, the equation of the tangent is that. So if this point is 1, when a is, what else do we find? 3. When a is 3, it's going to be 2 times 3x take y is equal to 3 squared. Running out of paper, that's going to be 6x take y is equal to 9. So when a is 1, this is the equation of the tangent. when at the point where a is 3, this is the equation of the tangent. Alright? And so what you can see is the point of contact for the tangent would be, think about it, the point of contact when a is 3, it's 3 and 3 squared, isn't it? So it's 3, 9. When a is 1, it's 1 and 1 squared, so it's 1, 1. Okay? So, these 2 points at which the tangents touch the curve, coming from the same external point, would be 1, 1 and 3, 9.